All right, so for my SAT takers, here is today's do now. Shown above is a slope field for which of the following differential equations? Pause the video, give it a try, and check in if you want to verify your answer. All right, the focus of today's lesson is models for population growth. Our focus today is what is called the law of natural or exponential growth. It is expressed mathematically by the differential equation dp dt is some constant k times the population. Note, for example, in bacterial growth, that there is this constant, right, that shows that growth. In this case, this is times 2 because the population is doubling each day. So we say the rate of change of the population with respect to time is some constant times the initial population. Example 1. The rate at which a population of fruit flies grows is assumed to be proportional to the number present. Suppose there are 100 fruit flies initially, so at time 0, and after 3 days there are 200. Find an expression for the number of fruit flies at, of the population at time t is bigger than 0. Okay, so we know that dp dt is some constant times p. Note this is always true for population growth. We would like to solve this equation for a particular solution. So let's move the p to the left-hand side. So we have 1 over p dp is k dt. Let's integrate both sides. We get the integral of 1 over p with respect to p, which is ln of p, absolute value, equals the integral of k with respect to t is kt plus c. We'd like to get rid of the ln, so we'll do base e on both sides. E, e, we're left with absolute value of p is e to the kt times e to the c. Now, note we'll call this constant 1. E to a constant is a constant, so this is a constant times e to the kt. Now, because population can't be negative, we'll remove the absolute value, and here's our generic formula. We know that the initial population, p of 0, is 100. So now we know p of 0, which is c e to the k times 0, is 100. We know k times 0 is 0, so we know c e to the 0 is 100, but e to the 0 is 1, so c times 1 is 100, or c is 100. Therefore, we know our population of fruit flies is 100 e to the kt. Now, we still want to know what k is, so we're given another piece of information. After 3 days, there are 200. So we know that there are 200 population and 100 e to the k times 3 days. We will solve this algebraically. Divide both sides by 100. We get 2 equals e to the 3k. And then natural log both sides. ln of 2, ln of e to the 3k, ln of 2 equals ln of e to the 3k becomes 3k, and then we divide both sides by 3. All right, so we get then that k is this 1/3 ln of 2, and then plugging this back in here, we see that p is 100 e to the 1/3 ln 2 times t. Now note e and ln cancel, so I'm going to regroup this. So we get 100 e to the ln 2, and then we still have this t and 1/3. Note the e and ln are going to cancel, so I have 100 equals e and ln cancel, leaving us with 2 to the power of t over 3. And there's our population function. Now, what's nice is we can plug in the values and make sure it works. So if I plug in 0, I have 100 times 2 to the power of 0 over 3, which is 2 to the 0, which is 1. 100 times 1 gives us 100. And then if I plug in 3, I get 100 times 2 to the power of 3 over 3, but 3 divided by 3 is 1, and 2 to the first is 1, and this is our population function. Part B. When will there be 1,000 fruit flies in the population? So we want this population function to equal 1,000. So note, we know P is 100 times 2 to the power of t over 3, and we would like this population to be 1,000. So 1,000 equals 100 times t to the power of 2 over 3. Divide both sides by 100. We get 10 equals 2 to the power of t over 3. Log base 2 of both sides, or I guess ln, either or. Let's do ln of both sides. Ln of 10, ln of 2 to the power of t over 3. The power will come out using our log properties. So ln of 10 is our t over 3 times ln of 2. Divide both sides by ln 2. So ln of 10 divided by ln of 2 is equal to t over 3. And then multiply both sides by 3. So 3 times ln of 10 over ln of 2 is our time. And then using a calculator, we had our 3 times ln of 10 over ln of 2, and we see that it is 9.965, which is going to take us here. So 9.965 days. And we would say then in about 9.965 days, there will be 1,000 fruit flies in the population. All right. Example 2. After a person drinks a cup of coffee, the amount of coffee in the person's bloodstream is 30 ppm. Suppose the amount of caffeine decreases or decays at a rate proportional to the amount remaining after 4 hours. There are 14 ppm left in the bloodstream. How many hours will pass until there are 10 ppm left in the bloodstream? Okay, so we've got a decay, and we know it's proportional. So proportional means the change in, let's say, coffee or caffeine population with respect to time is Kp, some constant times this proportion. So just like before, dP is going to be 1 over p dP equals K dt. Same as before, we integrate ln, absolute value of p, is kt plus the constant. Base e on both sides, absolute value of p is e to the kt times e to the constant, which becomes p, because can't have negative caffeine, is equal to c e to the kt. Now we know that initially there's 30. So we know the initial population of coffee, that sounds funny, is 30. So k times 0 is 30. So we can see c times 1 is 30, or c is 30. Then we also know that 4 hours later, there are 14. Okay, so our new function is p equals 30e to the kt, but we know that 4 hours later, so that is 30e to the k times 4 is 14. We'll divide both sides by 30, so we get e to the 4k is 14 over 30. ln both sides, so we get 4k is the natural log of 14 over 30. and divide by 4. So we get K is 1/4 ln of 14 over 30. Now, just like before, plugging this back in to this equation, we're going to see that P is equal to 30E, and then once again, we can see that the ln part, 14/30ths, and the 1/4 can join the t, but the ln and the e will cancel, leaving us with 30 times 14/30ths, which note is 7/15 if we reduce, to the power of t over 4. So there's our function. And then it asks us how many hours will pass until there are only 10 ppm. So we're going to set this equal to 10. And we're going to solve. So let's divide both sides by 30. So we get 1/3 is 7 over 15, the power of t over 4. Let's get rid of this base. So let's ln both sides. So ln of 1/3, ln of the right-hand side, so the power comes out front. Divide by that on both sides. So ln of 1/3 divided by ln of 7/15 equals t over 4. And then multiply by 4 on both sides. So 4 times ln of 1/3 over ln of 7/15 equals the t. And then using the calculator once again, see that it's going to take about 5.76 hours for that caffeine to decay. So what did we say? 5.76. So T equals 5.766. Sorry about my handwriting. Hours. And that's pretty much it. If the majority of you can finish the Unit 7 personal progress check, then tomorrow we can do an in-class review to prep for Friday's quiz.